So in this question, we have two parallel planes. We're told that the first plane, whose equation we're looking for, contains the line given by the following parametric equations. We've drawn that plane in a black color, and we've drawn a line to represent the line given by those parametric equations. And then that black plane is parallel to this red plane whose equation is given to us. Now, to find the equation of the black plane, we need two pieces of information. First of all, we need a point that lies on the plane. Now that's not too bad because we have a line that is on that plane, and that line will contain an infinite number of points. We can find one of those points. For now, we're just going to call that point P0. Again, this point lies not only on the line, but also on the plane. And to find the coordinates of that point, we can go back and look at the equation of the line, and we could substitute any value of t that we wish to get coordinates of a point on the line. It's probably easiest to substitute 0 in for t, so let's go ahead and do that. Now, since we're substituting t equals 0 into those parametric equations, we're going to get the coordinates of a point on the line and also on the plane. Those coordinates we will call x0, y0, and z0. So for x0, we're going to have 1 plus 0. Remember, we're substituting 0 in for t. This equals 1, of course. And then for y0, we're going to have 2 minus 0, giving us 2. And then for z0, we're going to have 4 minus 3 times 0, which simplifies to 4. So gathering all that into one point, we know that our point, P0, will have coordinates 1, 2, 4. So that's the first piece of information we need to get the equation of that black plane. The other piece of information we need is the so-called normal vector. Now, every plane has a vector that runs perpendicular through the plane. We call that the normal vector. And if we go back and look at our original diagram, we can see that these planes are parallel, and what that means is that the normal vector of the bottom plane, the one in red, will be the same normal vector as the upper plane. So in other words, the normal vector for the two planes will be the same because those planes are parallel. Hopefully you can see that the normal vector through the red plane would be identical to the normal vector through the black plane. So all that means is that that normal vector is perpendicular to the red plane. It's also perpendicular to the black plane. Okay, so how do we get that normal vector? Well, we look back at the equation of the red plane that was given to us, and it contains these so-called direction numbers. These are basically the coefficients of the variables. This has a coefficient of 1, of course. Those direction numbers would give us the normal vector of that red plane. So for the red plane, the normal vector is 5, 2, 1. And of course, that means, as stated earlier, that the normal vector for the black plane also is 5, 2, and 1. So that's the second piece of information, along with the point that we found earlier. Let's go ahead, gather all those data, and plug it into the so-called scalar equation of a plane. So right here is the scalar equation of the plane. We have to plug 6 numbers into that equation. We're going to take the point, and we're going to plug the coordinates of that point into the x0, y0, and z0 spots. And then we're going to take our normal vector, our a, b, and c, and plug that into the corresponding spots in the equation as well. So let's go ahead and do that. There we have it, and this is perfectly acceptable as a final answer. A lot of times you'll see your teacher distribute these coefficients, so we'll go ahead and do so just to clean up the equation, or at least put it in a different form. So we'll have 5x minus 5 plus 2y minus 4 plus z minus 4, and then often we'll combine all of the constant terms. So negative 5 minus 4 is negative 9, and then minus another 4 is a minus 13. So now we have 5x plus 2y plus 1z minus 13 equals 0. And then you would add 13 to both sides of the equation. We have our final answer, 5x plus 2y plus 1z is equal to 13. And that is the equation of the plane. Thanks very much for taking the time to watch this video. If you're interested in making a small donation to my cause, I would greatly appreciate it. Of course, please don't feel obligated to do so. I appreciate you taking the time to watch regardless.